All right, this is number 41 on lesson 3.7. Here's the problem. Find the 2 points where the curve x squared plus xy plus y squared equals 7 crosses the x-axis and show that the tangents to the curve at these points are parallel. And I believe it also asks you to find out what the slope of the tangent lines would be at those points. So the first thing is we have to find where the graph crosses the x-axis. So if we think about that, we don't really know for sure what this curve looks like maybe, but we know when it crosses the x-axis that the coordinates are going to be some x-coordinate, but the y-coordinate we know will be 0 at both of these points. So maybe we have an x-coordinate, let's call this maybe x sub 1, let's just 0, and x sub 2, 0. So we have two x-intercepts. At both x-intercepts, we know the y-intercept, the y would have to be 0. So what we can do is put 0 in for y in the equation, solve for x. That'll give us these two x-coordinates. So I'm going to put 0 in for y here and here. So that would give me this, x squared plus x times 0 plus 0 squared equals 7. So that simplifies to x squared equals 7. Square root of both sides, x equals plus or minus the square root of 7. So what I've just figured out is that this curve, we don't know what it looks like for sure, but we know it crosses the x-axis at the point square root of 7, 0, and at negative square root of 7, 0. So to find the x-intercepts, you put 0 in for y. That should be something you learned in a previous class, but didn't know if you'd remember that or not. Next, once you find these 2 points, we're supposed to show that the tangent lines are parallel. So to get the tangent lines, I'm going to need to find the derivative of this expression. So the derivative of x squared would be 2x. Derivative of xy, I see multiplication between 2 variables, so I'm going to have to use the product rule. So I'm going to take x times the derivative of y, which is dy over dx, plus y times the derivative of x, which is dx over dx, or 1, plus the derivative of y squared, which is 2y times dy over dx. Remember, you need to think of this. Your outside function is the square. So I multiply by 2, take that 2 down to a 1. By the chain rule, I copy down the y, and then multiply by the derivative of y. That's the reason I have these 2 things. Equals, and then the derivative of 7 would be 0. At this point, you can either plug in your numbers for x and y and then solve for dy over dx, or you can solve for dy over dx first. I think on this one I'll solve for dy over dx first. So I really got that term plus that term plus that term plus that term equals 0. So keep the terms of the dy over dx on the left side. Subtract the 2x over to the other side. Subtract the y over to the other side. That's going to leave you with this. X times dy over dx plus 2y times dy over dx equals negative 2x minus y. Subtracted them over. That's why they're both negative. Next, factor out the dy dx out of here. That will leave you with x plus 2y right there. Equals negative 2x minus y. And then finally, divide by x plus 2y on both sides. This is multiplication. When you factor out a dx over dy over dx, that's multiplication. So to get rid of that, you're going to divide. So dy over dx. If I divide here, that will disappear. Divide over there, I'll end up with this. Negative 2x minus y over x plus 2y. Now what I want to do next, now that I have my derivative, which, remember, gives us the slope of the tangent line. Now I want to just plug in these numbers and show that the slope at this point is the same as the slope at this point, so the tangent lines must be parallel. So let's do that. Let's find the slope of the tangent line, and also be the slope of the curve at the point negative square root of 7, 0. So all I'm going to do is, into my derivative, I'm going to plug in negative square root of 7 for x and 0 for y. gives me negative 2 square roots of 7 over negative square root of 7, which cancel the negatives, cancel the square root of 7s, comes out to a slope of 2. So what that's telling me is that at this point, the slope of the curve is 2, and also the slope of the tangent line would be 2 right there. Now let's find the slope at positive square root of 7, 0. So again, we'll find the derivative by plugging in square root of 7 in for x and 0 in for y. So I'm going to have negative 2 times the square root of, hold on here. Let me back up a second. I think I made a mistake. It was the first time I was plugging in negative square root of 7, right? So let me back up a second. When I plug in, this should be a negative right here. So a negative times a negative would be a positive. Should I do this right? So this should actually be negative 2. 2 divided by negative 1 would be negative 2. So actually, let me correct myself. My slope right here at this point, negative square root of 7, 0, should be a slope of negative 2. Okay, corrected. Now let's go back into the second slope I'm trying to find. Plug in positive square root of 7 for x, minus 0 for y. For x, put in positive square root of 7, and for y, put in 0 again. And you're going to get negative 2 square root of 7 over square root of 7. Those will cancel. I'll get negative 2 for a slope. And the problem tells me that I'm supposed to be showing that the lines are parallel. So because we have the same slope, that implies or tells us that these two tangent lines, where the graph crosses the x-axis, would be parallel because they have the same slope. So, you're going to make mistakes like I made up here, small mistakes. You just have to learn to catch them. Be real careful as you're plugging things in. Negative signs are things that cause a majority of our problems probably when we're trying to simplify. So be careful when you make mistakes like I did. Try to catch them. Try to keep your work neat so that you can find your errors easily.